One really useful thing we can use binomial expansion for is finding a certain term in a really long polynomial. So this binomial is to the 10th power. What I do not want to do is I don't want to distribute this all out and FOIL it and do all of that. I also don't really want to plug it into the binomial theorem and figure out what the polynomial would be. Instead, I just want to know, right, what's the fifth term? What's the coefficient of the fifth term? So we can do that by using the binomial theorem and just doing one singular, finding one singular term. So using this formula, this is going to be our A. Negative 4y squared is our B, right? Taking the negative with because there's a positive in the formula. And then n is 10. So when we go to plug this in the summation, I don't actually want the sum because I just want one term. So I want where n is 10, and I want the fifth term in the expansion. But remember, whenever we're doing this, we always start with 0. And since we start with 0, the fifth term, 0, 1, 2, 3, 4, is going to be the fourth term in our series. So n is 10. We're interested in the fourth term. Times a, which is going to be 2x to the n minus k. So 10 minus 4. And then times b, which is negative 4y squared to the k. All right, then we just got to get to simplifying this. Go to our calculator in order to do this in the TID4, right? We go to math, probability, then plug it in. And you should get 210. Then 2x to the 10 minus 4, well, that's 2x to the 6th. So 2 to the 6th is 64, and then x to the 6th, and times, well, negative 4 to the 4th power is going to be 256. And then y squared to the 4th, y to the 8th. Right, so we're going to get a really big coefficient here, and that's totally fine, right? Simplifying by multiplying those coefficients, those constants, and we get this very nice number. Times x to the 6th, y to the 8th. And that's our fifth term in our polynomial.